So a lot of you are, that's really good to see, but it's also really interesting that a lot of you are not currently or want to be. I can see how many people have answered, and I know how many people are on the call, so I'm trying to figure out in my head whether to wait or not. That's really interesting that over 30 of you were already working in this space. I'm sure that you'll be really interested to see the findings of the report that Zach is going to present. Right, that's really good. Oh, we've got a few more people. Right. Now we've got a good idea of what the balance in the room is. Please can we have the next question? I was extremely excited to get EnergieSprong today for this webinar, and anybody working in, a lot of people working in the off-site, modern methods of construction space and retrofit will have heard of their model and seen how it can be a real game changer. So it's great to see that some of you already know about that, and a lot of you it's brand new to you, which is why we've got an expert on the call today to tell us about it. Fantastic. Please can we go to the next question? And what do you want to take away from this webinar? Give us some key ideas, and then I promise I'll hand over and get you the good stuff, the information, not me. Wisdom. I want wisdom from everything I go to. That's a good answer. Collaborations, yep, great. And I'd really, as I say, if you're happy to share your details and want Zach or anyone else to contact you after this call, you can put that in the chat. And just an increased understanding and knowledge around retrofit. Well, that's great, because that's what the purpose of this Lunch and Learn and the purpose of the school is to increase that knowledge, have a better knowledge and understanding of retrofit, and obviously, as somebody's mentioned there, how that links into sustainability and what it means for us in the built environment sector. It's not those who are just working in retrofit now. We all know the scale of work that is going to come about for retrofit. There's been someone the other day who told me retrofitting the buildings in the UK is the biggest piece of the biggest project since post-World War II in changing our homes and buildings. We have to do this, and we have to do it quickly. Right, fantastic. It's really good to know what this is. Can we go back to the slides, please, Alfie? Right, and I did promise that it'll be enough of me now. So I'm just going to pass over now to Dr. Zach Gill. He's got a PhD in systems engineering, which focused on low energy homes and the impact of occupant behaviours. He's been a building performance specialist with 15 years experience. So at one point, he did tell me that someone had described him as the building performance mafia. Take that how you will. He is the co-author of the British Standard 40101 on building performance evaluation, and he is currently part of the PASS 2035 steering group for domestic retrofit, and with a specialisation in that monitoring and evaluation piece. So his insight is going to be extremely useful today, and I'm sure we're going to learn a lot. And with that, I'm going to let him talk about EnergieSprong, not me. Thanks, Zach.
Thanks, Holly. Thanks for the introductions. Alfie, if you close the slides, I will pop my ones up. Thank you. Should be that one. Can I just check you're seeing just the slides and not the notes or anything like that?
Yeah, we can see that on full screen. Thank you.
Great. All right. Thank you, everyone, for joining. So, yeah, I'm going to give you a bit of an insight into what EnergieSprong is and what the EnergieSprong model is. Very useful that there's lots of people in the room who aren't aware of what it is, because I often find I'm talking to people that do, and it's slightly less fun then because it's not new stuff. Yeah, that will hopefully give you a bit of an insight into what the whole model is around and how we're trying to sort of shake up the retrofit market and come up with a better way of doing it that's actually got funding behind it and got performance at the core of everything. So yeah, I'll probably talk for about half an hour, and then we should have a good sort of 15-minute for Q&A at the end. So I think Holly's going to keep her eye on that Q&A box. So pop your questions in there as we go. Yes, so what is EnergieSprong? That's we're going to cover that first. And then I will talk about the performance spec that underpins EnergieSprong. And then we'll look at a recently published, it was at the end of during last year, but a performance report that covered our sort of initial pilot projects and the findings that we had from them. So I'll go through a few of the results there to hopefully kind of captivate your mind a little bit about, you know, why we want to integrate performance measurement into everything that we're doing, and what we can learn from that, and then what the next steps are for retrofit in the UK. Because as we all know, there is a big challenge, as Holly mentioned. You know, the number of homes that need to be retrofitted per minute seems to increase every minute, as we're not doing enough. So yes, hopefully we can do more when we all know better ways to do it. So I will start at the top. What is EnergieSprong? Funny sounding term because it started in the Netherlands. So there it stands for Energy Leap. And the intention is to do deep retrofit. So that's retrofitting all of the things you might think about retrofitting on a house at one point in time, and doing it quickly and efficiently, cost effectively, maybe area based. So you've got that economy of scale because you've got lots of properties in an area that are similar archetype, and you're driving them instantly to sort of net zero or zero carbon homes. So rather than the traditional piecemeal approach in the UK of let's fund cavity walls, let's fund boiler changes, let's fund a bit of external wall, window, whatever it might be, but doing them individually, it's looking at that whole picture of what that home actually needs in the long term. The outcomes are quite varied. There isn't a standard blueprint for an EnergieSprong home. We do tend to look at the moment for relatively simple archetypes, so quite boxy homes, because one of the solutions that we think is going to really help us in the long term is to move towards much more off-site produced insulation panels, windows, energy pods. So all of the elements can really be controlled in a factory. So we know that the insulation is good, we know the air tightness is good, we know things are fitted together well, because we do see that being an issue in the UK, you know, especially with the conditions we've had recently, you know, trying to get traditional labour to install external wall insulation when it's freezing cold temperatures outside, you're not going to have much luck. So producing offsite and upscaling that is one of the approaches that we have for that. But in the UK, that hasn't always been possible. There isn't a big supply chain for doing that yet. So part of the EnergieSprong mission is also to drive that supply chain and collaborate, as was mentioned in the you know, in the what we want to get from this the webinar. So help kind of join people together. So join housing providers with the supply chain, with the performance experts, with the EnergieSprong concept, and all work together to achieve that retrofit goal of net zero or zero carbon homes. And what that's meant so far is that we do have homes that look very different. So we've got this is a traditional cavity construction that actually focus very much on filling that cavity and then installing the energy systems around it and working on the floor. This one top right was done in traditional external wall insulation, in keeping with the local vernacular. This one bottom left, that was an external wall insulation system, so an off-site construction. And the same on the right, you might have seen that picture quite a lot. It does get used a lot whenever EnergieSprong is mentioned. That's one of our first projects in Nottingham with these cross-wall properties. And it's, you know, quite a stark contrast to what they were before, but a big step change there. Again, off-site produced panels there. Now, the latest thinking is we do want to move towards a bit more archetyping, because we think that to scale up retrofit, actually we need to start pushing these solutions that work for people who have properties that look like that, you know, and that those solutions can apply, because there is a lot of cost and time in doing redesign and new solutions. But if we've got solutions that already work, we can start rolling them out. So that's like the kind of next phase post-piloting. The things that are covered, I've talked about these previously. So, we want to get to that net zero in one go. That's really what I mean by deep retrofit. So we're tackling all of those issues, once we're going in and disrupting that house, because, retrofit is disruptive. There's no avoiding that. But if you do disruption over many years with lots of different bits, it can be more disruptive than getting everything done in one go. So that's our working logic. This one that's circled here is really key, and I'm going to talk about this heavily in this presentation. So the guaranteed actual performance, that really underpins how this can stack up, and I'll discuss more about that in future slides. Offsite, we think offsite, as I said, is the way forwards to get those economies of scale and get that quality in the production line. It doesn't mean it's the only way. It's just, we're trying to drive that supply chain so that it is possible in the UK. We think about retrofit more as a business case. So, the cost savings, we want to access them to be able to help fund that high capital cost up front of doing deep retrofit. And we want to improve things for the UK, make housing conditions more affordable, make warmth more affordable, help the grid by reducing loads on the grid, by having lower demand in these houses. So the way that it works at a very high level financially is there's going to be capital cost for doing the retrofit, because you're going to be putting in external insulation, you're going to be putting in new heating, you're going to be putting in solar panels, some options about battery storage and other elements, and we don't constrain that. We just set a specification and then people design what will meet that. But what that will end up doing is saving the resident costs, because it will take away their gas bill completely, because they won't have gas anymore. So they'll get rid of the standing charge and they'll get rid of whatever they were paying for gas. And their heating will move over to electric, but it will be very efficient heating because the house is well insulated, and typically it would be a heat pump providing that heat. It doesn't need to be, but it typically has been. I've not seen any that aren't yet. So then there's the savings that have been made. We then turn into what's called a comfort charge. Now, that helps over a long period of time, say 10 to 30 years, recover some of those costs of the actual retrofit, so that the business model can stack up for housing providers, housing associations, etc. And there's also other savings for housing providers who do it, because there's going to be lower maintenance costs, there's going to be lower issues with possible damp and mold in those homes, lower issues with rent arrears, because with the energy being more affordable, there's less issue with not having enough budget to pay the rent. So we make sure that this is the total of the costs afterwards are the same as or less than they were before, and then the home has also increased in comfort. So we sort of turn those savings into a thing called a comfort charge. Now, maybe the long-term pipe dream is, there's zero bills completely, because the retrofit has done so much that we've completely got rid of, grid electricity use and everything else. But we're not there yet. There's still more advancement needed in terms of technology and insulation to be able to get there. But we're certainly making good impact, and trying to shift towards that. In terms of what we've done in the UK at the moment, this is slightly out of date. There's more like 100 pushing on 200 at the moment, pilot homes in the UK, and we've got lots that are completing this winter. And then we've got a big pipeline of homes that are, in that kind of, they're the right kind of archetypes, and they're housing providers that we've worked with, or local authorities. So there's a growing pipeline, and we really see that as being critical to how we can get the deep retrofit happening, because it brings costs down by having area-based retrofit and having this supply chain that can provide, rather than tens of their retrofits, they can be providing hundreds or thousands at a time. So then they can really invest in factories to build the products and the quality control that goes around that, and the servicing and maintenance elements afterwards. So, all of that scale kind of really helps bring down the costs. Now, I've mentioned it already, so that one of the things, and as I circled on this slide here, about guaranteed actual performance really underpins what we do. So I'm just going to step you through briefly what the performance specification covers. And then I'll talk about the examples from the pilot homes and the performance measurement and some of the pros and some of the cons and the things that we've learned from that so far and what we need to do better next and what we're going to kind of carry on doing. But yeah, the performance spec is really critical for us because we don't tell people what to do. So we don't say, thou shalt make sure the walls are 0.15 U value, or the air tightness is 2, or it must have a heat pump and it must be this size and this spec. We don't do any of that. We say that the performance is based on outcomes. So the house needs to have comfortable temperatures all year round. And we do specify what they are, but they're comfortable. It needs to have enough hot water each day for the residents to use. Now they can use more or less, but we need to have an allowance, essentially, like a little bit like a mobile phone contract. It needs to have enough electricity for household needs. So again, people can use whatever they want in there, but we must ensure that our designs and the actual performance of those is generating enough electricity from the PV and possibly from battery storage to be able to supply the household electricity needs. And a really big one is it's got to look good, feel good, sound good. People have got to want to live in those homes. They've got to have curb appeal. We work with a lot of housing associations and local authorities where, you know, you really look at sort of deprived areas or areas that need investment and the housing is tired and it's, you know, not then treated well. And you can make such a big step change by actually having this kind of care and attention and this really big change aesthetically that make people really kind of buy into living in those homes and wanting to live there. So there's more in the spec, but essentially it covers kind of all the critical elements of what happens. And then that for the designers, they then start going, okay, so I'm going to use this insulation system and it's got this kind of U value. And that means I need to add this kind of air tightness and I'm going to put this much PV because my roof is shaped like this. And, you know, they then start working through that kind of archetyping. So you can't, I think there's a bit of confusion for people that do know EnergieSprong in thinking, oh, I can go out and buy an EnergieSprong. Really, EnergieSprong is the concept around the performance guarantee and this funding model where the savings from the resident can sort of feed into that long-term capital repayment, including maintenance savings cost and stuff. So there's a lot of subtlety to it, but on the face of it, it's trying to make big step changes in the performance of the homes, of existing homes in the UK across the board. Now, the design, I won't go into this in detail, but this is maybe what the design output might look like. So we'll check that the designer is meeting our requirements for space heating demand. So we know that that home is going to be an efficient home in reality in terms of thermal efficiency. And we know that it's going to have enough hot water allowance. This one's saying, right, my model has said there's going to be 122 litres per day of hot water allowance for the resident. And we'll check that against what the spec says and say, yeah, okay, that's enough. They can use more or less, but we know that if they use that amount, that the home would run efficiently. We tend to set and agree what the sort of tenant electricity allowance is. So normally it's 2,300 kilowatt hours per year. That's a fairly sort of median value of electricity usage in the UK. Again, if people use more, that's fine, but these things will get monitored and separated out. So we can quite easily identify if a home is using sort of more grid electricity than anticipated in the design. We can find out, is it because that tenants are using more things and that's fine, or is it because that something's not performing and then we need to go back and actually check and resolve that issue. Net energy consumption is really key for us as well, and we've certainly started to see in recent projects that we do have ones that are net zero. So, you know, they're producing more energy over an annual basis than they consume off the grid. So they are getting to that net zero level. We gradually are increasing that, or decreasing technically, that target. So we're moving more and more towards all of the projects being net zero. But we have to work with the supply chain there in knowing what the insulation values are and what the performance can be achieved. So again, that's that's where we're improving on as we learn from these pilot projects. And yeah, circled here at the bottom is about tenant energy costs. So I said on the earlier slide, we want them to be the same as or less than. Actually, the target that's written in the spec is 40% reduction. And then we get into discussion about how much is applicable for certain housing types and certain areas. But we're really driving that to be lower cost for residents than it would have been before, particularly with energy cost increases. So if they hadn't had the retrofit, how much would they have been spending compared to having had the retrofit? That's the key thing to sort of check. So yeah, there's lots embedded in the model, and this is not unfamiliar stuff for designers. The thing that's a challenge for them and for the providers of this is that it gets measured in reality. So all of these elements are being measured, and all of them are reported back at least on an annual basis, and that underpins that performance guarantee, which can then say, is this home working like it was meant to work, or is there some reason it's not working and the resident shouldn't be paying the amount that they are paying? Or should I go in and fix something? Or should I learn for one of my future schemes not to use that bit of tech, but to use that bit of tech instead? So, really closing that loop on learning from what we're doing, which has been a challenge for the industry because most people have never been asked to do that before. Most people have worked in traditional measures where it's a lot about compliance. So, you might get your SAP model or your EPC rating that says, yes, I've achieved this standard, and off you go, happy as can be. But whether that's actually happening in reality isn't checked generally. So EnergieSprong are really changing the industry by doing that. And that's a big part of the collaboration there to help the whole industry move towards not being scared of performance measurement, but actually embracing it and going, well, if I learn from it, then I can consistently have higher quality, better performing products that my clients are going to enjoy and relish being in. So that's really good for business in the long term. So I'm going to talk you through some of the outcomes of performance measurement that we've had from our pilot projects so far. So we released a report earlier last year, and it covers the first, it covers 69 of the properties from 5 different schemes that were all part of the pilot. So a nice range of the sort of properties, a nice range of the archetypes and the housing types, from mid-terrace to flat to end terraces. So kind of everything covered in there to get a really good broad picture of what was going on across the schemes and what we can learn from that, and therefore, what we might change on future schemes. So I'll happily share the link to that, whether it's in the chat or via email. I'll get Holly to send it out afterwards. So if anyone's not had a look at that, then I can send the link out to it. But I'll chat through the high level results from it here and a few extra things that aren't in it as well. So one of the first things that we check is a high level check against what the performance spec said it was going to be, what the design said it was going to be. And there's a few key parameters that we look at, and then there's more, which I'll show on the next slide. So we've already talked about net consumption being a really important thing. So how much energy am I pulling off of the grid versus how much am I exporting to the grid? What's my net consumption? Because that affects the carbon emissions of these homes. Fabric thermal performance is there's some quite new techniques for being able to measure this. You might think of it like a miles per gallon rating for the house. So we can now measure the thermal efficiency of the property. So kind of ignoring what the resident's doing, we can just tell how good is the property. So the combination of the windows, the doors, the air tightness, the floors, everything, and then compare that to the design number. So that's a really useful sort of almost compliance test, a bit like air tightness testing, where you might say, right, if my target was 4 and I achieved 3.5, I've done better than my target. So we can start doing that with the whole property, which is really beneficial. We can look at the space heating consumption. So how much how much energy is being used for space heating in that property, again, compared to what it was designed to do. And is there any reason to be concerned about that? And then a factor that affects that would be the performance of the heat pump. So how efficient is the heat pump, again, compared to what it was designed and guaranteed to be? And then lastly, this one really links back to the net consumption, is the PV generation. How much energy is being generated from those PV panels compared to what the design was supposed to be? And we'll see some interesting things in here. So most are within, well, all of these are within 10% of what the design was meant to be. But we're finding that there are areas that we'd like to improve on. So the heat pumps in some of the pilot projects were running less efficient, and some of the PVs were outputting less than we were expecting to. Now, the PV is quite explainable, because traditionally what's happened in the pilot project so far is that we've had an archetyping type approach. So you might have 20 properties that are being retrofitted, but you have 1 or 2 archetype designs that relate to those, and then that's what the performance guarantee is set on. But that then doesn't include any slightly strange orientations of properties, or a tree in front of a property that hasn't been accounted for, or even situations where the inverter is turned off for a period of time. So actually in the data, it looks like it's not generating as much. So PV is actually very, very predictable. But this one tells us what we need to do is make sure that when we're going through the design process, that we're looking for all of those little possible adjustments on individual properties that might make that PV not generate as much as we thought it was going to. So quite an easy one to absorb that. Heat pumps, that's one that we want to work with the technology providers and the installers and the residents to understand which bit of those systems can we change to make sure that we're getting really high COPs. So coefficient of performance, that is how much heat we're getting out of the heat pumps versus how much electricity we're putting in. Because we obviously want to see all of these dots in green above the line saying, right, we're overperforming all the time. That means we can start kind of having better benefits all around. So heat pumps, I think there is a combination of all of those things. Are they installed exactly as they should be? Are they commissioned as they should be? Is the heating controls being used in a way that you might expect them to be, or that's most efficient for the heat pump? Is there an issue with the heat pump, full stop, and actually we just need something to be maintained or checked on it? So yeah, one for improvement, and we certainly can see heat pumps that perform really well, and we want more of them. So anyone out there who has lots of data on their heat pumps that's performing really well, we'd obviously more than happily talk to you and find out if we can integrate them into our projects. We're very data driven. So anything that actually works in reality, that's what we want to know about. These ones have been performing well. So net consumption, fabric thermal performance, and space heating, they've been performing very well. So we're happy generally that we're getting to where we need to be in terms of targets. I'll just show a quick example of the fabric thermal performance, just so you can get a concept for what that looks like when we look at the data. So there'll be a design target, which on these graphs is shown as the red dotted line. And then each home is individually measured to gauge, it's called the HTC, the heat transfer coefficient. Getting a bit nerdy there, but that's the miles per gallon rating for the house. And each of these are individual properties, and then we can see on average we're performing very well, but there is a bit of variation in there, but actually it's covered by the confidence interval of those values. So whilst this one might be one to watch, it's not one to be very concerned about immediately. Similarly with these other example homes, so again another 5. Again, each one is generally performing within expected tolerance. House C and House A might be ones to look at in the future, or keep monitoring over years. We keep monitoring anyway, but we can then start doing that to see if anything's changed, or if there's any defects in terms of the insulation installation. Is there a thermal bypass we didn't know about, or has something not been insulated when it should have been? So we can check that immediately, almost as like a compliance check, and validate that what's been said was going to be installed was installed. Now then, when we look at the overall performance of the homes, we then start thinking about kilowatt hours, energy that's consumed. And this graph has one extra that isn't in the report. So these first 4 were in the report, and subsequently we've had another scheme that's had 12 months worth of data. So I've been able to pop it in here. And what they're showing is the orange and the yellow in the background were the pre-retrofit energy consumption. So gas in orange and electricity in yellow. And then the post-retrofit electricity consumption, because they don't have gas anymore, is the dark blue, and then the export is the light blue below the line. And what you can see here is the potential for EnergieSprong and deep retrofit approaches to make just such a massive change to the energy consumption of those homes, even when you look at the worst performing of those homes in each area. So this little error bar covers the best home and the worst home. So you can see even on this one, I think that one, which is about closest to the top, was about 50% improvement on the pre-retrofit energy consumption, and the same here. So even if you've got a little bit of underperformance, going through the deep retrofit process and getting all of those measures done just has such a massive difference on the energy consumption, and therefore affordability of those homes, comfort within those homes, that we really think that is just critical for us to be able to achieve good quality deep retrofit in the UK. An added benefit is thinking about things like mold risk. Again, we do measurements. So where we can, we want to measure as much pre-retrofit data as possible as well, so that we can get a really good baseline for what's happening. It's not always possible. We're getting better, and the supply chain's getting better at being able to do that, and engaging with the residents when we know which schemes are going to happen to get a bit of pre-retrofit winter monitoring in. So this is an example output of one of the schemes. And pre-retrofit, we had some really high mold risk identified. So that was based on measuring the temperature and humidities. And in particular in the bathroom, but also in the other rooms in the house. So, it wasn't localized to one area. Same house post-retrofit, we've now got an extra sensor because we're monitoring the underfloor conditions. Everything's moved to low risk. So because we're keeping the house warmer, you've got the insulated walls, so you've not got as much issue of condensation and therefore mold growing. You've got good quality ventilation in there. You've got proper air tightness in conjunction with that ventilation. You've massively reduced that mold risk. So that's something that I think is often hard to put a value on. I mean, obviously in recent weeks and months, there's been more highlight on it, but we think that's just such a critical bit. It's about the people living in the homes, and that leads to examples of happy tenants who've lived in these retrofitted homes. So this is one of the not the original Nottingham scheme, but a future one. There's been 2 more phases of works in Nottingham, and we get comments back, everything is perfect. This was actually a great decision, a massive improvement. It is a good gift. So, we want more happy tenants. And that's one thing that you can really achieve through good quality deep retrofit. And the last bit to link with that is one of the things that wasn't covered in the performance report, but hopefully will be in the next version, is we now have a method for doing better occupant surveying, so particularly pre and post retrofit. It aligns with the British standards that Holly mentioned about, this BS 40101 on building performance evaluation. And this enables us to get that feedback from the residents, more so than anecdotal comments. I mean, anecdotal comments are great for case studies and testimonials, but like I said, we're data driven. So using this now standardized survey format, we're able to do measurement pre and post retrofit and find out what things have we improved, have we made anything worse, and what's left to do, if we missed anything that we should have accounted for. And an example of what that might look like before I wrap up and then we go over to Q&A. Is something like this. So red, amber, green. So these are the post-retrofit scores in red, amber, and green. So obviously things that are in green, not to worry about. Things that are in red, still work to do. And then the little crosses on this graph are showing the pre-retrofit scores. Now this is for an example scheme because the schemes that are happening this winter, we should get better pre-retrofit measurement. So this is a home that's gone through retrofit, but we're going to get, this is one example. We're looking to get this on sort of all of our schemes as time goes on. And you can start seeing the things that you've improved massively. So energy use, for instance, here has massively improved from the resident's point of view. The ability to control the heating has improved as well, because we've installed new systems and new control systems. But there's things that still need to be done. So actually, we are having some issues in this property with humidity in the wintertime. So ventilation control was an issue for the tenant, and therefore the ventilation overall was identified as an issue, particularly related to the bathrooms and toilets. So this is a really easy one then to look at the data and go, okay, we can go back and resolve that. We can make sure that those terminals are connected, that everything's working, that everything is commissioned properly in isolated cases, to make sure that you're getting that performance from those systems. And then there's things that are maybe a bit outside of what might be encompassed in the retrofit project, but that if we could resolve in the future would be really beneficial for the residents. So phone signal comes up quite a lot. Also things like TV signal with internet, but in particular in this house, phone signal was really bad. So if there was something we could do to sort of add on to the deep retrofit, because we're doing lots of works anyway, that might improve phone signal inside, you might start winning over more residents and kind of just increasing that happiness and comfort and satisfaction within homes, because they're things that people worry about. So yeah, the surveying is designed to cover all of those kind of elements about what a good home is like, and then be able to do this pre and post retrofit. So yeah, hopefully in the next iteration of the performance report, you'll see more of this data based on the next pilot projects. But I will wrap up there. Yeah, I'll share my contact details separately afterwards if anyone wants to get in touch directly. But Holly, I think we'll go over to Q&A.
Thank you so much, Zach. That was really good. And I think the performance guarantee in that model, as you said, is very different to what we're seeing currently in construction. And I thought it was really important how you ended talking about that tenant, the tenant focused approach. How is it actually improving for the people who are living there? And another thing that I'm just thinking about, I know that on this call we have people who are working in heat pump manufacturing and other things. I think, as you said, it'd be interesting to get their views and connect with you and EnergieSprong after this to look at why are the performances, why is it not as good as we thought it was going to be? As you said, the PV was explainable and that is different. So yeah, so many things have sprung to my mind, and I'm sure have sprung to the mind of everybody, because I can see the Q&A filling up. So yeah, I'd ask everyone now to get your questions into the Q&A box, please. And whilst we do that, I'll give you something to warm your minds up. We're just going to go to Menti one last time, if that's okay, Alfie. So if you can all go back to the Menti, which was the code, I've put something in 25881064, and just think about, what do you think the model describes means for retrofit at scale? And people can you can put that in whilst we talk, and I'll go straight to the questions so that we don't run out of time. But that Menti is now open, and you can just put in what you think the model Zach described for retrofit at scale. Let's keep the conversation going, and I'll be sharing that with everybody who's on this call after the call. So Zach, I'm going to speak to you whilst people put in there, and I'm just going to ask you the first questions that are in the Q&A. So we've got two in the chat first, and then I'll go to the Q&A. How long do you plan to keep monitoring data for the buildings for post retrofit? So you looked at, you mentioned, we need to go back and re-monitor these buildings. How long does that go on for after the retrofit?
So the monitoring systems continually monitor. So generally the contracts that we've had so far and are working on this winter operate for 10 years, but really the financial model starts stacking up over a longer period of time, because as many of us will know, retrofit, the capital cost of retrofit is quite high. And actually, even with energy prices having increased, the savings that you can make on energy still take time to pay off. And then you've also got maintenance, savings, etc., to account into it. So when we first started out, we were looking at 30-year time periods. So we'd be saying we want to retrofit and bundle up those savings over a 30-year period to enable that kind of financial model to work in the long term. Typically, that's what we're aiming for, but the contracts will be looking at 10 years. So they'll sign up to say, right, I'm going to monitor and report every year for over this 12-year period. But actually, generally what that means is that each house has a live monitoring system in it. So if something comes up from the resident, if they ring up and say, I'm having a problem with my heating system, can someone help me out? Then we can look at the data, or the data can be looked at by the provider or whoever is maintaining that property. And you can then quite quickly get to the bottom of, why might that be happening? Is it because something's gone wrong, or is it a setting, or is it that something's broken, or is it that actually everything's working all right and we need to do a bit of better tenant engagement to help them use that system? So kind of looking at what the outcome might be, and it's often not straightforward, but by having that data, you can then ascertain what's going on. So it's live data in data management on all of those properties. So
thank you. And you mentioned kind of that tenant engagement piece with the technology and the usage, and there's a question in the chat about how you manage that engagement pre and during the retrofit. I know we've talked about it is the disruption. There's a lot of ways where you've reached out to people whom are coming into upcoming schemes to manage their homes. Do you have a specific approach that you take as EnergieSprong to how do we engage these tenants?
There isn't a specific approach at the moment. There's a try and work in the best way possible with the people involved in each project. Now, what that's leading to is starting to get to outputs where we can say, actually, what we've seen is the best way to do it is, the RLO engages at this point in time, and this is the kind of information that goes across to the resident. So we're starting to standardize that information a little bit that goes back and forwards. But generally what it takes is knowing which houses you're going to be working on, and then being quite open and honest with those residents about what's involved and what's going to happen. And with having this case study information, it's a lot easier for then people to be able to engage with it and go, oh, I can now visualize what that looks like, and talk to other residents who live in EnergieSprong homes, especially if it's in your local area. So we're doing lots of work in the Nottingham area, for instance, so people could, go to that street and go and have a look at them and go, oh, okay, that's what's being talked about for mine. So there isn't a one-size-fits-all approach for residents. It's about engaging and looking at it from their perspective, and that's part of the the end that I was talking about, in getting that feedback from the residents. That helps us start closing that loop a bit better, because I think in the engineering world and construction world, we're quite good at boxing up the residents and sort of putting them just slightly outside of the stuff that we're responsible for, but really, we need their feedback and engagement to make sure that the retrofit is optimal for them.
Yeah, and I think that'll be really important going forward, not only in domestic settings but in commercial buildings as well. As we start to retrofit those, we need them to be fit for purpose.
Well, what are buildings for? They're for the occupants, so we can't separate them completely from it.
I'm keeping on that theme with the next question, and there was a question about fairness and climate justice, and how for further information around the comfort charge that you mentioned. So if the tenant, I'll read out the question and then I'll explain. So people are struggling to pay their energy bills. It seems unfair to put the cost of retrofit through the comfort charge on the tenant, especially if they're in social housing or low-income communities. Should this not be paid for by the company profiting from the asset, i.e. the landlord or housing provider? Or is this a matter of misunderstanding? So when you're talking about this comfort charge, who is it that's paying that? Is it the landlord, the building owner, the social housing provider, or the tenant themselves?
Yes. So if you imagine what costs are involved, so you've got your cost of the actual retrofit to happen, you've got your materials, you've got your labor, you've got all of those bits and bobs, and then you think about the savings that will be made from doing that retrofit. Some of those savings are linked to the housing provider. So if you've reduced the maintenance costs, if you've if you've helped them maybe there's a bit of grant funding that comes in as well, to sort of offset some of those costs. Generally, it's not very much. So there are some costs that will go back to the landlords or housing associations. The energy cost saving is hard to disentangle from the resident. And what we found is that for the model to stack up over time, you need to recoup some of that energy cost saving. So in the Netherlands, where the EnergieSprong concept started from, they have some different policies and different metering setups. So they have net metering, which means if I import 10 kilowatt hours of electricity, but then my PV generates 10 kilowatt hours of electricity and sends it back to the grid, I have zero bill. I don't have to pay anything.
Right.
In the UK, it's very different. We're charged 35 pence at the moment for importing a unit of electricity, and we're only paid 5 pence if we send it to the grid. So there's a real imbalance there. So what we try and embed is that the costs reduce for the residents. So yes, people are struggling to pay, and we're going to help that by reducing those costs overall and increasing the comfort in those homes, because now they're well insulated, they stay stable. So, even if you turn the heating off for a few hours, the temperatures stay stable, not like they used to. But some of that cost is recovered through the comfort charge. So, if you were paying £1,500 a year, maybe post retrofit, if the energy costs don't keep increasing, you're now paying £1,300 a year. But some of that is comfort charge going to help that fund more retrofit in the future. And I think that covers the fairness bit and the equality, because what we want to be able to do deep retrofit on many, many millions of homes in the UK. But with the costs associated with retrofit, that's very hard to do deep retrofit, because there isn't enough money flying around. So we need to make all of those financial streams work for getting deep retrofit happening. And it is a long-term view. And, that's why we started many years ago and iterating and growing. But yeah, some of the housing providers have been taking that cost on themselves. So they haven't charged a comfort plan. And therefore the resident is just getting all of the benefit of the retrofit at zero cost. But actually, is that fair and is that equitable? Possibly not. But we do spend a lot of time, working with the residents to understand their existing bills and their existing use of their home beforehand. And if you do have vulnerable tenants or tenants in fuel poor situations, then the situation might be slightly different for them. But again, that's sort of on a case-by-case basis. But if you step back and look at the bigger picture, you go, right, we're going to take some of that saving to help fund that big retrofit so more homes can happen in the long term.
Thank you. That's really kind of cohesive. And because we're running out of time, I just wanted to say that you said at the beginning that you're really looking forward to collaborating with other people, and obviously there's quite a lot of people on the call now, and I don't know if there's anything you want to say before we finish. And as I say, we will be sharing contact details, so if your question wasn't answered, it can be. Is there anything you'd like to say or encourage people to get into contact about with EnergieSprong around collaboration?
Well, I think as mentioned on one of the slides about when the heat pumps were mentioned, we need more supply chain who can deliver, demonstrably good retrofit in the UK. So we're happy to talk with anyone who's doing systems that might be considered efficient, in terms of homes. So heat pumps, insulation, inside or outside, windows, PV systems, battery systems, grid management services, all of those kind of things will form part of what deep retrofit is. So, we're always open for discussion. Like I say, we don't have a blueprint of what an EnergieSprong proposition looks like. That's where the design ingenuity and the innovation comes in. So yeah, I mean, we'll circulate my contact details and I can always put you in touch with others in the team. But yeah, always happy to talk with people who've got new ideas or new innovations to sort of bring forwards, and possibly that can work under the EnergieSprong model.
Yeah, I'm really excited to see how this conversation goes, because there has been questions in the chat about why are the heat pumps underperforming, and talking around data around that. And so, as you say, you need to be working with the people who are providing these solutions and the technology to look at why that is. And as the performance guarantee model means that a variety of different manufacturers, installers, and people who are doing these innovative solutions can be involved in the EnergieSprong model to hopefully, as you say, roll out deep retrofit at scale. So we've come to the end, and it's gone really fast. And I do apologise if your question wasn't answered, but as we say, we're going to share the Zach's contact details. Please do the feedback survey. Let us know what you think. And yeah, if Zach, you want to put your details in the chat now, but I will also be sending Zach's details out and mine as well in the follow-up email. So thank you very much for coming, everybody. I really appreciate your time, and thank you very much, Zach.
Thanks, everyone.